So here's the rest of 1.5. I'd like to break things into shorter videos because I know you guys can pause if you're at home, but sometimes even for me, it's nice to kind of take a step back and see how things turn out. So try to keep them short, but maybe multi-part so you can kind of take your time and watch them individually. So the first part of 1.5 was focusing on single or simple inequalities where you had a less than sign or a greater than sign or less than or equal to, but you only had one of those. So now we're going to talk about a compound inequality. So the word compound means multiple, like a compound sentence has multiple parts. Compound inequality means that you're going to have more than one inequality. So for example, when it's written, you're going to see the words and or the words or. So for and to give you like a real life example, if I said that in order to sit in the front seat of a car, you have to be 100 pounds and 5 foot tall. That is something that meets two conditions. You have a joined, or if you say I'm going to go to a movie, and the people, in order to pay a regular price, you're going to have to be over 5 and under 55, something like that. So you have that combination. I always think of the word and. I tell students, think of the word and as a sandwich. You are sandwiched between two values, and the word and is in sandwich. So you are sandwiched between like 5 and 10. And inequality will look something like this. Give me a second. 5 is less than x is less than 10. This is an and inequality because the value that we're referring to is between, you'll often hear that as well, 5 and 10. So what this is saying is 5 is less than the number and the number is less than 10. So you're sandwiched between. When you graph an ands will look like sandwiches. You'll have an end spot, They may be filled in, maybe one side's filled in, one side's not, and you'll connect the dots. So that's what your and is going to look like. Like this one would be an open circle at 5, an open circle at 10, and you'd be connecting. So ands connect between two values. The inequality signs when you write an and should always point to the smaller number. So if I write it like this is like the fastest way to write it. Those inequalities are pointing to the 5 because 5 is smaller than 10. The other type of compound inequality is called an or inequality. Or means you also have two things, but it's almost like two separate options. So if I'm going to go to an amusement park and I want the discounted price, I either have to be under 6 years old or over 65 years old. So I have two, think of it as like the extremes, the opposites. I love to tell students that when you think or, think opposites, because that's what it's going to look like and that's how it's going to be written. And I'll show you when we go through this what that means. So again, you have like almost like the two extremes. So we're going to write them, we're going to solve them, we're going to talk about word problems. So one way you'll see an and is you'll actually see the word and. The other way is going to be like I did up here where I wrote it all at once, which is actually a little simpler. But I'll show you both because I want to make sure you're comfortable. So I'm going to subtract 1 here. I'm just going to solve these like I did with the single ones. It's like two separate problems. So I'm going to divide by 2. So I have 3 is less than x. If you don't like it written like that, you could also write it as x is greater than 3. Means the same thing. And then for this one, I'm going to divide by 3. So I get x is less than or equal to 6. So that means my answers, and it's a set of answers, is between 3 and 6 because it's anything that is bigger than 3. And at the same time, it also has to be less than or equal to 6. So if I said to you, give me a number that's bigger than 3 and less than or equal to 6, hopefully you would say 4 or 5 or 3.5, something like that. When you draw it, you're going to draw both numbers. Please put the smaller number to the left. So 3 comes before 6. You do not have to put all the numbers in between. You might have answers that have a huge interval in between. So we're going to put an open circle here, meaning it is everything not including 3. We're going to put a closed circle here because it's everything including 6. And we're going to connect the dots. And there is my sandwich. So I am sandwiched between 3 and 6. Now, I do want to kind of show something that I'm going to go into in another video, but I'd rather start talking about it here. Another way to write that, if you don't want to write it with all this stuff going on here, you could also write it as an interval. You could say that it's between 3 and 6. And let me show you the notation I'm using. The parentheses, and I'm going to talk about this later, so this is just kind of an introduction. I promise I'll do more of this later. If I put a parentheses next to the 3, that means it's not included. If I put a bracket next to something, that means it's included. So you'll notice I have a parentheses next to the 3 and a bracket next to the 6. That's another way to write this interval, saying it's all those numbers between 3 and 6, including 6, but not including 3. Another way to see an and inequality is like this bottom one. I actually like this look better. To me, it's easier to work with. It's easier to write as well. Whatever's going on in the middle, you need to get x by itself. So I need to subtract 1. If I do it in the middle of this inequality, I also have to do it on the left side and the right side. So I'm going to have -6 is less than or equal to 2x is less than or equal to 8. Then I need to divide by 2. If I divide by a negative, I'm going to flip all my inequalities. I didn't, so they're going to stay as is. So I'm going to have -3 is less than or equal to x is less than or equal to 4. A great way to check your work, make sure your inequalities are pointing the same direction. You can't have one pointing left and one pointing right, and make sure they're pointing to the smaller number. So when I draw this on my number line, I'm going to have my -3 and my 4. -3 comes first because it's smaller. They're both closed circles. I don't know why it does that. Stop. And then I'm going to connect in between. So that's an and inequality, or again, I like to think of it as a sandwich or a sandwich graph or a sandwich inequality. The other option are the or ones. The or ones can take a little bit more time, but they're also pretty easy. The reason or ones can take a little more time is you really have to treat them separately. You can't do a lot of stuff at once like we do with the ands. So I want to get, for this first one, I want to get k by itself, so I'm going to subtract 7. So k is greater than or equal to -1. And then I'm going to do the same thing, get k over here. This time I have to subtract 8, so I get k is less than 3 minus 8 is -5. So now when I write it, -5 is smaller, so it needs to go on my number line first. -1 will go here. -5 has an open circle. -1 has a closed circle. And now what's going to happen when you draw this? If I draw something that is less than -5, it needs to go to the left. Those are all the numbers that are less than -5. If I want to draw all the numbers that are greater than or equal to -1, I want to go this way and see what it looks like. It has this opposite look. That's what OR graphs are going to look like. You have those extremes. So you have the opposite ends. I think I'll talk in another video how I write the interval for that. Some of you may already be familiar with it, but we'll definitely get to that in a bit. Next one, and that one's done. Next one, we're going to get x by itself. So we're going to subtract 5. So we have -2x is greater than -5. Divide by -2. Notice I divided by a negative, so I need to switch the inequality. For this second inequality, I need to distribute. So I'm going to have 4x plus 4 is greater than or equal to 28. And again, as you're working on these, if you want to pause, try them yourself. If I start going over it and I'm going too fast, you can always just rewind the video a little bit and go through to make sure you can catch up. That is the nice thing about the videos. They don't go away. So if it takes watching it twice or pausing it a couple times, you're good. Divide by 4. So you get x is greater than or equal to 6. So now when I put them on my number line, 2 is smaller than 6. So I'm going to have a 2 and a 6. I am looking for, oh, I didn't switch I said I switched my inequality and I didn't. I am sorry. This is the number of mistakes that I'll make, but hopefully I correct them before I finish the video. So for this, I'm sorry, I said switch inequality, I didn't. So it's x less than 2. So I'm going to put an open circle there, and I want everything less than 2. Greater than or equal to 6, I'm going to put a closed circle, everything bigger than 6. And again, you have this opposite look. When you do an or one, you may have both circles be open. You may have both circles be closed. You may have one of each. Same thing with the and. You're going to have inequalities that maybe the two, can think of them as endpoints of the segment or the rays, can be open or closed. Finally, I want to talk how do we transfer this to real life? I've mentioned a few amusement park examples, height of driving, something like that. So here's a couple examples of when you would see this in real life and how we actually write them. These will actually be pretty quick. So if I'm making t-shirts, I want my t-shirt fundraiser, I need to earn between $500 and $1,000. Every shirt that I make is going to have a profit of 8. I want to know how many I need to sell for a successful fundraiser. First, the word between, it should indicate that it's going to be an and because you're sandwiched between two values. So first I need to figure out, and you can grab like a calculator, and this you don't need anything fancy, you can use your phone, of how many t-shirts are you going to have to sell to get to those boundary numbers. So if a t-shirt makes a profit of $8, well, what's 500 divided by $8 to figure out how many t-shirts I have to sell? So 500 divided by $8. Let's see. Do I have a calculator close by? Actually, I think I do. Give me 1 second. Maybe I don't. I'm not going to mess with it. I can do it. Grab a calculator and go ahead and do 500 divided by 8 and get your answer. And then do the same thing with 1,000. So go ahead and do 1,000 divided by 8 because you want to figure out how many t-shirts. Now, one thing to keep in mind with t-shirts is you can't buy or sell part of a t-shirt. So 500 divided by 8 is 62.5. So 63, just going to round up to the nearest whole one, is the lowest amount of shirts I have to sell. And then 1,000 divided by 8 is 125. So 125 is the most that I have to sell or to get this successful fundraiser. My t-shirts are going to be in the middle. I'm just going to call it X. My inequalities should point towards the smaller number. You will need to sell. This one was exact. The 63, it was a little bit underneath, so we can put an or equal to there as well. So you're going to need to sell between 63 and 125, including 63. 63 would be successful, 125 would be successful in order to have your fundraiser. For the next one, we're looking at discount amusement park tickets, kind of something I mentioned. You're either going to get those if you're under 6 or if you're at least 65. So again, the word or tends to stick out in these. So if I want to write a compound inequality and say, well, you could be under 6. So under 6 does not include 6. So there's one group of people that would get discounted tickets. Or if you are at least, again, at least means greater than or equal to 65. Not really going to ask you to do much as far as drawing inequalities that are real life. It's more about writing them and making sure you understand how they work. So there you have your compound inequalities, your and. You should be able to draw and, you should be able to solve and you should be able to recognize it with word problems. Same thing with or. You should be able to solve an or inequality, draw on a number line an or inequality, and see how it shows up in real life.